Hello my dear students, today we will take one more example on columns and struts. Let us take this example. Figure shows a built-up column consisting of 150 mm by 100 mm RSJ, means riveted steel joist with 120 mm by 12 mm plate riveted to each flange. Calculate the safe load the column can carry. If it is 4 meter long, having one end fixed and the other hinged with a factor of safety 3.5. Take the properties of the joist as area is equal to 2167 mm square and Ixx is equal to 8.391 into 10 raised to 6 mm raised to 4 and Iyy is equal to 0.948 into 10 raised to 6 mm raised to 4. Assume the yield stress as 315 MPa and Rankine's constant alpha is equal to 1 divided by 7500. Here the built-up column is given like this, okay, and already that built-up column's area Ixx and Iyy is given here, okay. So the total length of the column is 4 meters, so you can convert into millimeter, so 4 into 10 raised to 3 millimeter, and factor of safety is given, it is 3.5, and okay, yield stress is 315 MPa or 350 Newton per millimeter square, and the area of the joist it is given here, Ix is also given and Iyy also given. Okay, now what you have to do, built up column already is there, that is this one, okay, this portion here, this area and Ixx and Iyy is given. Now we have to calculate this plate area Ixx and Iyy also, that is not given here. How we can calculate? First, from the geometry of the figure we can find that area of the column section, area is equal to now area of this column, built up column, plus this area of this plate, okay. So what is that? Area of this built up column is given 2167 and this is 2167 plus area of this we have to see, okay, this flange plate, that is, what is that area? Area is equal to 120 into 12 B into D, 120 into 12, but there are two plates both on top and bottom, so 2 into 120 into 12, okay, plus this area of this column, built up column. So when you add this you get 5047 mm square. So this is area of the column, whole column, okay, area of this flange plus area of this built up column. Now like this you have to calculate Ixx and Iyy also. How you can calculate Ixx? What you have here, this is given, okay, Ixx of built up column is given, that is 80 here it is 83.91, okay, into 10 raised to 6 it is given here, and it is not 83, okay, it is 8 only, by mistake it is written here, okay, this is 8.391 into 10 raised to 6, that is Ixx of this built up column. Now you have to calculate Ixx of this. We can see here this is like a T section right here, this flange and this comes here, this is T section, and all of you know now how to calculate Ixx for T section. What is the formula to find Ixx in the case of T section? That is BD cube divided by 12 plus AY square, right? So for that, first you have to calculate what is y. What is y? Y is distance from neutral axis to the CG of that section. But here you can see that this is a symmetrical section, right? So the total depth is 12 plus 150 plus 12, this 12. So total it becomes 174 mm. Okay, total depth. Neutral axis lies exactly at the center. This is given already in the problem. So what is that? 174 divided by 2, that is equal to 87. So here also 87, here also 87. So you no need to calculate the position of the neutral axis. Otherwise, you have to calculate what is the position of the neutral axis. For that, you should use the formula y bar is equal to a1 y1 plus a2 y2 divided by a1 y1 a1 plus a2. But here that is not required, because the neutral axis, it is told that it is exactly at the center. So the position of the neutral axis is now 87 millimeter from the top and 87 millimeter from the bottom, because total depth is 174. So 174 divided by 2 is 87 mm and 87 mm. So now you know the position of the neutral axis. So you can calculate what is y bar, y1. Okay. So what is the formula? Here the two T sections, you can see here on top also one flange and bottom also one flange. Okay, let us consider this as a 2. So 2 into BD cube divided by 12 plus A into y square. What is B here? B is 120 and D is 12. So 120 into 12 cube divided by 12 plus A y square. What is area here? Area is 120 into 12. Now, what is y here? Y is always distance from neutral axis to the CG of that section. Now, I'm considering here, okay, this is y here for this. What is this distance? See, total depth is equal to 87. Okay, this CG is here. This is 12 meters. So CG is at a distance of 6 meter. 12 divided by 2 is 6. Okay, I want the distance from here to here. What is the distance? 87 minus 12 divided by 2. That is 87 minus 6. That is equal to 81. Okay, so you get this 81 because 87 minus 12 divided by 2. Okay, so that is equal to 81. So now you can simplify this. Okay, already this built up column I-axis is given here. Consider that plus 2 times of this flange plates are there on both top and bottom. So 2 into BD cube divided by 12 plus AY square. Okay, you get 27.32 into 10 raised to 6 mm raised to the power 4. Now I-axis is done. You have to calculate IYY. How we can calculate IYY? IYY is nothing but B cube D divided by 12. Okay, here also again you have to consider the built-up column IYY that is already given here, that is 0.948 into 10 raised to 6. Write that first. Plus, now this plates IYY you have to calculate. Here 2 are there, 2 plates. That's why it is you have to multiply by 2 into, now the formula is not BD cube by 12, it is B cube D divided by 12. Okay, so what is B cube? B is now 120 here, this is 120 and this is 12. So what you will get, you have to substitute B cube, that is 120 cube into 12 divided by 12. Okay, add this, you get 4.404 into 10 raised to 6 mm raised to 4. Okay, now IXX and IYY you have to take the lesser value. Which is the lesser value here? IYY is less than IXX. Therefore, the column will tend to buckle in YY direction. Okay, so we'll take I as now equal to IYY, that is equal to 4.404 into 10 raised to 6. Okay, now after this, now you have you already have shown how to calculate IXX and IYY. Next, you have to see what is the effective length of the column. Here, it is given condition that one end is fixed and other end is hinged. So, what is L effective? L effective is equal to L divided by root 2. What is L? It is given 4 meter. So 4 into 10 raised to 3 millimeter divided by root 2. So that is equal to 2.83 into 10 raised to 3 millimeter. Now after that, for Rankine's equation, you required K. So K is minimum radius of gyration, that is equal to square root of I divided by A. Okay, now I lesser value you have to consider, that is 4.404 into 10 raised to 6 divided by A. What is area? Area is 5047. So substitute that, you get K is equal to 29.5 mm. Once if you know all these values, now you can substitute in the Rankine's crippling load equation, that is PR is equal to sigma C into A divided by 1 plus alpha, or some books they have written it as A also. You can consider any one, either alpha or A, divided by LE divided by K into LE divided by K whole square. Sigma C is 315 into area is 5047 divided by 1 plus what is alpha, 1 divided by 7500 into LE is 2.83 into 10 raised to 3 divided by 29.5 whole square. So you get PR is equal to 714 into 10 raised to 3 Newton or 714 kilo Newton. So you have Rankine's crippling load. You can calculate the safe load. How you can calculate safe load? Safe load is equal to crippling load divided by factor of safety. So crippling load is 714, factor of safety is 3.5. So you get 204 kilo Newton. Okay. So this also one of the very important types of problems usually comes in the exam. Okay. Mainly already built up column details will be given. Only you have to calculate this flange area and IXX and IYY. Okay, so this is like T section, so you have to consider IXX using the T sections formula, that is BD cube divided by 12 plus AY square. Once and also here one step is reduced. Actually neutral axis position is given here, it is exactly at the center, so you have directly what is the position of the neutral axis, so it is easy to calculate what is Y. I hope all of you understood. If you have any difficulties, we can discuss in the class. Okay, thank you.